So we go back to our experimental results, where we measured a and b, and we thought that the relationship might be b is proportional to a to the n. What we're going to do is we're going to find a way of testing whether that relationship is true or not. So the first thing I want to do is I want to get rid of that proportional sign, because fish are slippery things that are difficult to get hold of. So we get rid of the fish, replace it with two fish fingers. But of course you can't have fish fingers without putting ketchup on. So we get b equals ka to the n. So a and b are numbers, and they're in an equation. So you can do things to numbers, but because they're in an equation you've got to do the same thing to the numbers on both sides. So what I could do with b, I could imagine it being written with a power. In other words, I can find the logarithm. So to find the log of b, I'm not going to bother writing base 10, I'm just going to write log. The log of b must equal the log of that lot, because that's the same as b. So the log of ka to the n. And then we think about our laws of logarithms. This is two things multiplied together, k multiplied by a to the n. And when we've got things multiplied together, to find the log or to find the power, we take the two separate powers and add them together. So the log of k times a to the n is log of k plus the log of a to the n. That of course is still equal to log b. And then the second law that we had, when you've got something raised to a power, to find the log of something raised to a power, you take the log of the something, you times it by the power. So that would be log b is equal to log of k plus n times the log of a. And just to make things a little bit easier to follow, I'm going to just swap those two things over, not changing anything other than the order of the equation. So log b equals n log a plus log k. It's exactly the same, I've just written them the other way around. So remember that a and b were numbers I got from an experiment. I put them in a table. I could add two extra columns to my table. I could add a column for log of a and get my calculator and work them all out. I can add a column of log of b and get my calculator and work them all out. So if we go back to the equation, I've got some values of log a and log b. I'm going to plot a graph. I'm going to plot the log b values on the y-axis. So that's like my y value. I'm going to plot the log a values on the x-axis. So those will be the x values on my graph. And then we'll look at what else we've got. Well, the x values, log a, is multiplied by a number, n, a constant. And we think about what the equation for a straight line is. Y equals mx plus c. So comparing the y equals mx plus c equation with the log b equals n log a plus log k, what that tells us is that this will give a straight line. And the straight line would have a gradient of n and an intercept of log k. So a graph of log b against log a will be a straight line. Of course we got this equation by thinking about the laws of logarithms. We didn't consider what the actual values were that we got in the experiment. So when we take our values and plot the graph, the values might give a straight line, but they might not. But if they do give a straight line, it means that they obey this equation. And if this equation is true, then this equation must be true, and 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 this relationship must be true. So that's how we test the relationship. If we think that b is proportional to a to the n, then we plot a graph. We plot log b on the y-axis, we plot log a on the x-axis, and if we get a straight line, then the equation is true and the value of n would be the gradient of that straight line.